So I mentioned NTS and the AIS technology for maritime tracking. So that's sort of the engineering side of it. On the commercial side of it, ComDev has developed or stood up a separate company called exactEarth. And exactEarth, again, it's a separate company, but it's a wholly owned subsidiary of ComDev. And its purpose is to market and sell the AIS data to different maritime organizations, militaries, coast guards, and whatever around the world. And a lot of interest has been generated. We've gotten contracts from the Canadian government, from the Danish authorities, and are in active negotiations with several others. And the key to this is not just taking these signals from space and the raw data itself. There's actually a lot of other people who are trying to do the same thing. The value added is in the processing of the data and the interpretation of the data. That's really the exactEarth service. So having what will eventually be a 10+ year database of ship movements, it's really a gold mine from the standpoint of any kind of, say, a commercial investigation or security investigation. As I said, these transponders are supposed to broadcast the identification, heading, and destination and speed of these of different vessels. Well, what happens if you've detected a vessel and suddenly, without explanation, its destination changes, or it turns, somebody's trying to go stealth and they turn off their transponder, or you found that there's two ships in different parts of the world that are reporting the same identification. That means somebody's doing something funny, and that means you send in the authorities to check out what's going on. And that's a capability right now that's lacking without the space component, without the exactEarth component, and that's what we're trying to bring to the market commercially. We're looking beyond exactEarth as well. So, satellite-based AIS is, we really believe, and we've made a significant investment, both in terms of internal R&D to develop the AIM-class bus and the infrastructure investments we've made in the Mission Development Group and the ground facilities, that this is the next big thing for Canada to be involved in, and that almost anything that you can do with a big, expensive, multi-billion-dollar, $100 million satellite, you could do almost as well or just as well with a nanosatellite or a microsatellite platform. I'll close off with, well, a bit of a total propaganda plug, I suppose, is as Tom has said, I've worked at a number of different space companies in my relatively short career, and at the risk of sounding kind of corny about it, I would say that ComDev is the best company that I've had the privilege to work with. And we're always looking for new people. We're very privileged to have in proximity Waterloo and other academic institutions that we do collaborative research on, and as pools for recruitment. So if anything that I've said tonight, and just ignore the stuff about me at the beginning, but any of the stuff afterwards is of any remote interest to you, I would highly encourage you to go to the ComDev website or talk to me. We're always looking for different people to come on board and join what I think is a really, really cool Canadian company that's doing some truly groundbreaking things. And we were recently voted one of the top 15 employers in the Kitchener-Waterloo area. So that's got to count for something. Just as a little bit of an aside, I think a lot of that culture comes from our CEO, John Keating. John is an incredibly engaged and passionate person, not just about the technology, but about giving back to the community, encouraging volunteerism, donating money for the MRI in the Cambridge Hospital, or the new indoor soccer field in Cambridge. And that really filters down to people. When people see that senior management actually has these high-level values, then it filters down for everybody to fill. So it is really the most positive place that I've ever been lucky enough to work at. And I hope to see many of you wandering the corridors of Honda as well. And my voice is just about to give out, so I'll close with, again, an appeal, not to riot like the Acropolis. And I hope, except for that stuff at the beginning again, that there was something I said that was at least of interest, and I'll be happy to take questions. I have a drinking problem. I'll take a question or something. Yeah.
Do you know if already there are parts in COM that are working on superconducting devices, or they plan to do something like that?
Yeah, we don't do a lot of materials stuff right now. One of the challenges of space, and I mentioned sort of conservatism, is things have to be space rated, so you get this weird chicken and egg problem that if something hasn't flown in space before, nobody kind of wants to be the first. Through the mission development group, we're trying to break that cycle. Trying to take a little more risk where it's warranted, doing these hosted payload type of demonstrations to prove new technologies. So in direct answer to your question, I don't know of any specific work in terms of superconducting applications for space right now, but it's entirely possible in the future. It's your fault.
Yeah. Can you comment on, so you've got several different buses that you operate after satellites. Can you comment on what types of applications aren't suitable for nanosatellite or microsatellite? What needs a bigger bus?
Well, for example, a lot of the optics stuff might need a bigger bus. I mean, this is just physics, right? You need, if you want to get sub-meter imagery or something, you need a large telescope, and that's going to impact the size of the spacecraft. Pointing requirements, potentially. ACS. Power is a challenge, potentially, although we're doing some internal R&D. I don't have the picture here, but we're doing some internal R&D for deployable solar arrays on some of these small platforms. So that's gonna mitigate some of that. There's always going to be a place for larger platforms, right? There's stuff that something the size of a JWST, which is like 2 tennis courts, or the Hubble Space Telescope. It's got to be that big because of its mission. But there's a lot of stuff, particularly in terms of comms, where you don't need very high pointing. Like NTS, I showed you, it doesn't even have a propulsion system. It's just it has no orbit control, so it's just well, not really tumbling, but it's just following the Earth. So there's a place for both, but there's more and more applications that you could start seriously considering on the microsat nanosat side. Yeah.
How much bureaucracy does an employee